Today we are going to discuss wave optics. In wave optics, we'll start with wavefront. What is wavefront, how it is produced, what are the different types of wavefronts. So all these we'll discuss in today's discussion. First, let's start. What is a wavefront? Wavefront is the locus of all the points which are vibrating in the same phase. So it is the locus of all the points which are vibrating in the same phase. So that locus, we'll call it as the wavefront. How do we get, first of all, these wavefronts? Suppose you have a particular source here. So it will give out the waves. It will be going in all possible directions. Suppose it is a point source, it is giving out waves in all possible directions. And suppose those waves are going with the speed c. Suppose I want to know the position of the wave after time tau. So that means the distance traveled will be c into tau. So all those waves which has originated at t equals to 0, they will be now at a distance of c into tau in all possible directions. That means we can also consider that if I have a sphere of radius c into tau and whose center is at the position of this source, then all the points which are lying on its surface, they all have originated at the time t equals to 0. And after time tau, they are at the surface of that sphere. So in that case, they all will have the same phase there, and this one will be giving you the wavefront. And if you want to know the exact position of the wavefront there, in fact, it will be always in perpendicular direction to the propagation of the wave. Wavefront will be always perpendicular to the propagation of the wave there at that particular point. So if you take all those tangential plane there, they will be forming the shape of a sphere. So you will get the wavefront at that particular instant. Like suppose if the waves are going in this direction, they are coming from a distant source. So here if I want to get the particular wavefront, we can draw a plane. This plane will be perpendicular to the propagation of the waves there. So this one will also give you a wavefront. All the waves which are there, or all the particles which are there on the surface of this plane, they will be in one phase. So that will be one wavefront. Let's take now different types of wavefront what we get. So types of wavefronts. First one is a spherical wavefront. A spherical wavefront is that which is spherical in shape and is produced by a point source. So if you have a point source at a particular point, it is giving out wave in all possible direction. In that case, this will give rise to a spherical wavefront there. Like suppose, so that means its source is your point source. This will be originated from a point source. Like again, we can show it here that suppose you have a point source at this point, it is giving out wave in all directions. So it will give rise to a spherical wavefront. So this is your spherical wavefront. So a point source will give rise to a spherical wavefront. Another one is your cylindrical wavefront. Now, cylindrical wavefront is cylindrical in shape and is produced by a linear source. So here, this will be produced by a linear source. Like suppose you have a linear source here. It will give rise to the waves in all possible directions. So they will be going there in all possible directions. So suppose if I take a cylinder, so the wave will be going in all possible directions there. And you have here wavefront which is cylindrical in shape. So this is the source here, linear source, and it is giving out wave which is giving you a cylindrical wavefront at any later instant. So this is giving you cylindrical wavefront, and that is given by the linear source. So this is your cylindrical wavefront. Because the waves are going in all possible directions. You take any plane there, tangential plane which is perpendicular to its propagation, that will give you the wavefront at that particular instant. So that will be cylindrical in shape. Third one is planar wavefront. Planar wavefront will be once again planar in shape and is produced by a distant point or linear source. So like here, what will happen basically? You have the waves coming out from a distant source, whether it is your point source or it is your linear source. So like suppose if you have the point source here, it is giving out wavefront which is a spherical in shape. So this is there when it is at this particular distance. Suppose if it is at larger distance, in that case the wavefront will be like this. Again, if it is at larger distance, the wavefront will be like this. Now you see the shape of the surface at any particular one. Its curved nature is gradually decreasing. It is more curved, then it is less there. So if the point source is at very, very large distance, in that case, the nature of the surface there will be almost like a plane. You can assume a plane surface as a part of a sphere whose radius is infinite. That means in that case, it is at a very large distance. So here, you will be getting the surface almost like a plane. Similarly, if you have a cylinder, again in this case also, if this is at larger distance, in that case the surface will become more and more flat there, because earlier it is the curve like this, then it is less, it is becoming more and more flat there. So a distant point or linear source will give rise to a planar wavefront. Now how will you represent that? Suppose you have the waves coming out from a distant source, so they all will be going almost parallel. And as we have said, that wavefront will be perpendicular to the direction of propagation of the wave there. So for that, if you take any planar shape there, then this will give you a planar wavefront. So these will be like the planar wavefront. You can represent it like this, as if it is going and perpendicular to its surface. So these are the planar wavefront. So these are the three types of wavefront which we come across. Let's now just take what will be the shape of the different wavefronts we can get in different cases there. Suppose you have parallel rays coming and it is falling on a convex lens. Here you have to draw what is the nature of the wavefront which will come out from this convex lens. Now in this case, if you consider, here what you can observe, the wave which is going through this particular part, that is the middle part there, which is the thickest one, the speed of the light wave will be less in this denser medium, and there in the upper part, its thickness is less. That means the distance traveled here is more, and here it will be less. It means to have the same wave front, here the wave which is going in this part, they will definitely travel distance which will be more as compared to the inner one or this middle one. That means if I now take their position for the different waves which is coming out, they may have a shape like this. So here their shape will be like this. That means the wavefront which will be coming out of that will have a shape like this. You can take it in a different way also. Like here, if we have the parallel waves falling on this convex lens, in that case, they will be meeting there at the focus. So this is the direction of their propagation. So here, as we have said that the wavefront will be always perpendicular to the direction of the rays there or the waves there. So here, if you draw a plane which is perpendicular to this, all these waves there, in that case, if you consider their nature, it will be something like this. Because here it will be perpendicular to this one, this will be perpendicular, this is perpendicular. That means the shape will be like a curved one. So this one will give you the wavefront when it is coming out of this convex lens. Or you can treat in another way also. If I have a point source here, how the waves will go? They will be just moving and it will be going. That means this is the particular focus of the lens. So the waves will be moving in this direction, they will be going parallel. So now it is the point source. So from point source, what type of wavefront you will get? A spherical wavefront. So this will be the part of a big sphere. So this will be the shape of the wavefront at particular instant. So that way also you can get the shape there. Same way will be there if you consider the waves falling on a concave lens. These are the parallel rays. When passes through this convex lens, now in this case, see, what will happen? The wave which will go through this inner part, that means this particular part, where it is thinnest, in that case, it will definitely come out fast. Whereas the wave which is going in this particular part will definitely have to travel through a larger distance. So in that case, they will be coming out there and they will describe the length which will be less in this part and more in the inner one. So that means their shape, if you consider, it will be something like this. So this will be the wavefront here. This is the shape of the wavefront. That means basically as the waves will be going in this direction, this will be the shape of the wavefront. Same thing you can treat in a different way. You have here concave lens. The rays are falling on it parallel. So after passing through this lens, they will diverge. They will appear to be coming out from this particular point, which may be the focus of this. And again, you have to draw a plane which is perpendicular to these waves which is coming out of it. Because the wavefront will always be perpendicular to the direction of propagation of the waves there. So if you consider the plane, in that case, its shape will be like this. So you will get this as the wavefront. So this is how you can get the wavefronts there. You can explain in either ways there. Like if you consider in terms of the distance traveled, and finally, because once they are on a particular wavefront, they at particular instant of time, they all will be in same phase. Here they have to travel lesser distance. Here they have to travel more distance. And here speed is less. So obviously even if I assume that they all are having the thickness like this. So here after passing through this particular thickness, the wave has come out and now it is moving freely in air with the speed same as the speed of the light. But here they have to travel larger distance here with lesser speed. So obviously the distance traveled by this wave when it comes out will be less as compared to the wave which is going from this. So the shape will be like this. So this is how you can get the wavefront there in these two cases. Similarly, suppose you have a prism, and if the rays are falling on the prism. So again, when the rays will be coming out of it, they will be now having their shape, which will be given by this. Because now you see, the wave which is going from this particular part, they will be definitely traveling there with larger distance. In the particular denser medium, here they will travel through smaller distance. So obviously in air they will travel larger distance as compared to the wave which is going from this part. So obviously you can assume that there the wavefront will have a shape like this. Or in other case also you can treat the wave as it is going, following the prism, and after suffering refraction they will be going like this. So if it is going like this, it is the perpendicular plane to them, so obviously their shape will be like this. So that way also you can treat.